My dear students, let me welcome you all to a new edition of physics. In this edition, we'll revise Unit 2. We'll try to answer some miscellaneous questions. Questions such as write the scientific term, write the scientific expression, make comparisons, explain, and so many other questions. So let's get started. Revision on Unit 2. First of all, we want you to make a comparison between helium, neon laser, and ruby laser. Okay, comparison between, yes, helium, neon, and ruby laser. First of all, the first point of difference is the active medium. Active medium in helium neon laser is neon atoms and a mixture of helium and neon atoms. Active medium in ruby laser is chromium atoms in the ruby crystal. Okay. What about the pumping process in each one of them, source of energy? It is electrical pumping, high DC voltage or high frequency electric field, or thermal pumping is used in helium neon laser, but optical pumping, flash tube wrapped around the crystal, is used in ruby laser. So electrical pumping in helium neon, but it is optical in, yes, ruby laser. What about the resonant cavity? Yes, in helium neon it is external resonant cavity, two separate parallel plane or concave mirrors. Okay, one mirror is placed at the side of one end of the tube, and the other is placed beside the other end of the tube. And resonant cavity in case of ruby is an internal resonant cavity. The ends of the ruby rod are polished and silver to act as mirrors of different coefficient of reflections. And last point of difference is the number of energy levels involved in the generation of laser. In helium neon, we've got 4 energy levels. Okay, 4 energy level scheme is involved in producing laser, but in ruby we have just 3 energy levels. 3 energy level scheme is involved in producing laser. And now we want you to make another comparison between diffusion current and drift current. Once again, we want you to make a comparison between diffusion current and drift current. Okay, what about diffusion current? It is the current which arises from the difference in concentration of the charge carriers in the 2 regions of the p-n junction. Let me say it again. It is the current which arises from the difference in concentration of the charge carriers in the 2 regions of the p-n junction. And what about the drift current? It is the current caused by the presence of the internal electric field set up at the n junction. Diffusion current originates from majority charge carriers. Diffusion current originates from majority charge carriers, but drift current originates from the minority charge carriers. Free electrons diffuse from n region to p region. Meanwhile, positive holes diffuse from p to, yes, from p region to n region. And what about drift current? free electrons move from p region to n region, and positive holes from n region to, yes, p region. Diffusion current is opposite to the diffusion current and much stronger than it. Drift current is opposite, of course, to diffusion and much weaker than it. Write the mathematical relation that expresses wavelength of the characteristic line, characteristic line spectrum of X-rays. The wavelength, first of all, we should try to obtain the energy of the photon emitted. It is the energy equal to the difference between the two levels, E2 minus E1, and it is equal to h nu, and nu is equal to c over lambda, so the difference equals h c over lambda. In this way, we'll be able to obtain the wavelength, lambda equals h c over the difference in energy. Okay, h is Planck's constant, c is the speed of light in space, and delta E is the difference between the two energy levels. Okay. The expression that gives maximum kinetic energy with which an electron freed from a photosensitive surface by light, having a frequency greater than the critical frequency. So let me say it again. We've got light with frequency greater than the critical frequency. This light is shown on a surface. Electrons are ejected. We want the relation that gives the maximum kinetic energy. Yes, it is h nu minus EW, and it is equal to half mv squared. H nu is the energy of the incident photon, EW is the work function, m is the mass of the electron, v its velocity. So we can say h nu minus EW equals h nu c. Nu c means cutoff frequency. So h nu minus h nu c is equal to half mv squared. And of course, h can be taken as a common factor. So between two brackets, nu minus nu c is equal to maximum kinetic energy, or maximum kinetic energy. The expression that gives the stopping voltage, the voltage needed to stop an electron freed from a photosensitive surface when using light, yes, with frequency greater than the critical frequency. Okay, once again, h nu minus EW should be equal to, yes, E V stopping, the energy. Okay, given energy is the product of charge of electron and the voltage. This voltage will be, yes, equal to the stopping voltage, since it is equal to the maximum kinetic energy of the freed electron. Once again, h nu minus EW equals EV. V here is the stopping voltage. We want the expression that gives the relation that gives mass of a photon. I believe all of you know it. Mass of a photon is given from the relation h nu over c squared. And h nu is the energy of the photon. So we can say it is equal to E over c squared. So either saying h nu over c squared or E over c squared. And of course, c is the speed of light in space, 3 times 10 to the power of 8 meter per second. And what about the relation that gives momentum of a photon? Okay, momentum of a photon is given by the product of mass and velocity. Velocity of the photon is denoted by c, so it is equal to mc. And of course, it is equal to h nu over c. Not c squared. C squared means mass. Okay, and we can say it is equal to E over c. And what about the kinetic energy of a photon? Okay, it is just h nu. So energy of a photon equals h nu. H is Planck's constant, nu is the frequency of the photon, and frequency is given, yes, by c over lambda. So we can say the kinetic energy of a photon equals hc over lambda. And what about the kinetic energy of an electron? It is half mv squared. M is the mass of the electron, v is the velocity of the electron. It's a velocity, and of course velocity squared. The relation that gives the wavelength of the wave that associates a moving particle, for example a moving electron. It is de Broglie equation. Wavelength is given from the relation h over mv. mv is the momentum, product of mass and velocity of the moving particle, and it is denoted by PL. So lambda equals h over PL. We call this de Broglie equation. The relation that gives the force exerted by a beam of photons when reflecting on a surface, when they are reflected on a surface. Photons exert a force. We want the relation that gives this force. Yes, force is equal to 2n h nu over t times c. N is the number of incident photons, h Planck's constant, nu frequency, t is time, c is speed of light. And of course, nh nu over t, energy over time, total energy over time, it is power. Okay. And also, since n over t is denoted by phi l, we can write F is equal to, between two brackets, phi l h nu over c. Okay, where phi l is equal to n over t. And as I said, we can say it is equal to 2 pw over c. Pw is the power. The expression that gives the momentum of the electronic beam used to examine an object in the electron microscope. Momentum of the electronic beam used to examine an object in the electron microscope. Or momentum of the cathode rays. The momentum of the electrons emitted from, yes, the cathode in College tube. They are all the same, and they are given by the same expression, which is momentum is equal to h over lambda, or PL is equal to h over lambda. We want you to give the expression that gives Wien's displacement law. Yes, Wien's displacement law, the product of lambda maximum and absolute temperature is equal to a constant. So we can say lambda maximum 1 over lambda maximum 2 is equal to T capital 2 over T1. T capital means absolute temperature. Okay. The relation used to estimate the radius of an orbit in Bohr's atom. Okay, the circumference should be equal to an integer of wavelengths, so the radius equals, yes, n lambda over 2 pi. The relation that gives the shortest wavelength in X-ray continuous spectrum. EV equals h nu maximum. What is EV? EV is the energy gained by the bombarding electron, gained from the accelerating voltage. Then this electron is stopped by one collision. So all of its energy is converted into a photon having, yes, energy h nu maximum. We can say it is equal to h, and instead of nu maximum, it is c over lambda minimum. So lambda minimum equals hc over EV. The expression that gives the number of positive holes in the n-type semiconductors. positive holes in the N-type semiconductors is the minority charge carriers. So we'll use mass action law. P is equal to Ni squared over N. N is the number of free electrons. Number of free electrons is roughly and approximately equal to the number of positive donors. So P equals Ni squared over the number of positive donors. And what about the expression that gives the number of free electrons in the p-type semiconductor? Once again, p positive holes equals, yes, number of negative acceptors plus free electrons. So number of positive holes is roughly equal to the number of negative acceptor. Okay, so we can say the number of free electrons is equal to Ni squared over P, and so Ni squared over the number of negative acceptors. And what about the expression that gives the current gain in a transistor? Current gain is denoted by beta E. Current gain is equal to the ratio between collector current to the base current, IC over I base. IC equals alpha E, fraction of the emitter current that reaches the collector. Alpha E times I emitter over 1 minus alpha E times I emitter. Of course, emitter current will be crossed out, so current gain equals alpha E minus, so current gain beta E equals alpha E over 1 minus alpha E. The relation that gives the phase angle between two rays coming from an object to a holographic plate when producing a hologram for the object. The relation is phase difference or phase angle is equal to phase difference or phase angle is equal to path difference times 2 pi over lambda. Let me say it again. Phase angle is equal to path difference over lambda times 2 pi. And now another type of questions. What are the factors affecting the dominant current, the factors affecting the dominant color of the radiation emitted from a glowing black body? Of course, it is temperature of the black body, temperature of the object. Factors affecting work function or affecting the critical frequency, of course, it is the kind of metal, kind of photosensitive source. Factors affecting kinetic energy of the electrons emitted from a certain photosensitive source. Kinetic energy of the electrons emitted from a source. It is the frequency of the incident radiation. So once again, we want you to mention the factors affecting the kinetic energy of the electrons emitted from a certain photosensitive source. It is, yes, the frequency of the radiation incident on the metal. And what about the factors affecting mass of a photon? Mass of the photon is given from the relation h nu over c squared. H and c are constant, so it depends on frequency. So frequency of the photon is the factor that affects the mass of the photon. Voltage, what are the factors? Yes, affecting the voltage needed to stop an electron freed from a photosensitive source. It is, yes, what about the factor? The electron is freed by light, of course, having a frequency greater than the critical frequency. The factors are, yes, the frequency of the incident radiation, frequency of the radiation incident on the metal. What are the factors that affect the wavelength of the wave that associates a moving particle? Okay, to determine the factors, you need to write de Broglie equation. Okay, the factors affecting the wave, the factors affecting the wavelength of the wave associating the moving particle. First of all, lambda is equal to h over mv, so mass of the particle and velocity of the particle. Both of them is called product of mass and velocity is the momentum. Factors affecting the force exerted by a beam of photons when reflecting on a surface. Of course, first factor is the number of photons, photons incident on the surface in 1 second. Frequency of the light. And what about the factors that affect the shortest wavelength in X-rays continuous spectrum? Shortest wavelength in X-rays continuous spectrum. Of course, it is the accelerating voltage. And what about the factors that affect line spectrum of X-rays? Yes, it depends on the kind of target, the material of the target used in the tube. As a matter of fact, the higher the atomic number of the target material, the shorter the wavelengths of the characteristic lines are. It means the wavelengths of the characteristic line spectrum will be decreased by increasing the number of the atomic number of the target. And what about the factors affecting conductivity of a semiconductor? And they are the same that affect resistivity. Okay, it depends on 2 factors. First of all, temperature of the semiconductor and the presence of impurities. And what about the factors that affect the momentum of a moving particle? Mass of the particle, this is the first, and of course, velocity of the particle. And what about the factors affecting magnification power of an electron microscope? The potential difference between the anode and cathode. The greater the potential difference, the greater the velocity of the electronic beam, and the smaller the wavelength of the wave that associates the motion of the electronic beam. This can be deduced from the relation lambda equals h over mv, de Broglie equation. When the velocity is increased, electronic beam is accelerated, the wavelength is decreased, wavelength of the wave that associates the motion of the electronic beam. What are the factors that affect the power of beam of photons incident on a surface? Number of photons incident on the surface in 1 second, the frequency of the incident light. And now we want you to write the scientific, or to mention the scientific term. A body which is an excellent absorber of radiant energy as well as an excellent radiator. Of course, it is black body. The product of the wavelength at which the intensity is a maximum, lambda maximum, product of lambda maximum and the absolute temperature of the radiating body is constant. It is Wien's displacement law, Wien's law. Okay. And the curves that represent the intensities of radiations emitted by a black body at different temperatures, we call it Planck's distribution curves. Detection of infrared radiations emitted from an object, we call it thermal remote sensing. So thermal remote sensing is detection of infrared radiations emitted from an object. Emission of electrons from some metals when irradiated with electromagnetic radiations of sufficiently high frequency. It is photoelectricity or photoelectric effect. Extraction of electrons from the surface of some metals by heating the metals. It is thermionic emission, and we use this in the, yes, cathode ray tube. It is thermionic emission. In this way, we've come to the end of this edition. Until we meet again, my best wishes to you all. Thank you very much.